Okay, so parallel lines are lines in the same plane that never intersect. They always stay the same distance apart, okay? So it's not just that they don't cross in the part we see, they would never cross, even if we kept going. Algebraically, from the equations, we will know that they are parallel. Anybody have a guess or no? The slopes are the same. So if the slopes of two lines are the same, those lines will be parallel to one another, and they would never cross. Perpendicular lines are lines in the same plane. Think of the plane as being, when I say the plane, like some flat surface, like your desk. Like the floor could be a plane. The ceiling could be an example of a plane, all right? So lines in the same plane that meet at right angles. And you might say, well, what do you mean right angles? Well, I mean like perfect corner. They meet at a perfect corner. Now, it doesn't mean that one has to be horizontal and one has to be vertical. If I actually took this and rotated it, those would still be perpendicular. So you might say, so any x, well, I could make an x and I could do like that would not, that's not perpendicular. That's intersecting, but it's not intersecting and making, like all four of the angles created would all be the same. That's what happens in a right angle. All of these, you'll see a little box sometimes, that means that it's a right angle. If you tried to stick a corner of a piece of paper in there, it would fit perfectly if it's a right angle. Algebraically has to do with the slopes again. The slopes now I'm going to use the word opposite reciprocals instead of negative reciprocal. Because sometimes when I say negative reciprocals, then people think it's always negative. But it's always the opposite sign of each other. So negative, when this next little section where it says what are negative reciprocals, that's the same thing as saying what are opposite reciprocals. Reciprocal means the fraction is inverted, flipped over. So opposite or negative reciprocals means I'm going to change the sign and flip the fraction over. So if it's 3/4, then it's negative 4/3. 2. What if I have a whole number? What's the reciprocal of a whole number?
-2.
So it would be negative, but it won't just be -2. So this is 2/1.
Oh, -1/2.
So the reciprocal is -1/2. So any whole number, remember that it means over 1. And so when I flip it, it becomes 1 over the number, and then you need to change the sign. So if I already have a negative, when I do the opposite or negative reciprocal, it becomes positive, and I still flip it over. Now, a 1 is kind of an interesting one because when I do the reciprocal of 1, it is still 1. So this is just -1. Because if I have 1/1 and I flip it over, it's still 1/1. but it does have to have different signs to be negative reciprocal. So these would be pairs of slope that would be perpendicular. And for 0, it's 0 and undefined. In other words, a horizontal and vertical line. Or if you have 0 on top and then the other slope gives you 0 on the bottom. So if I want to determine, yes, did you have a question? Okay. If I want to determine, how dare you look at me? You're okay. It was just kind of that question look, sorry. If I want to determine if 2 points form a line, and like these 2 points form a line, the other 2 points form a line. We're trying to decide if they are parallel, perpendicular, or neither. Neither would mean the lines cross, but they don't cross in the special way of being perpendicular. And before we go any further, need to introduce you to a little bit of notation. For parallel, I'm going to use this. It looks like the 2 L's, like 2 parallel lines, right? And for perpendicular, this upside down capital T means perpendicular. And then for neither, we can just put an N. So for our final answer, instead of writing out the word perpendicular, writing out the word parallel, I mean, you can, but you can just use that notation. So for my first pair, I have to find the slope, because that's how I can determine, because it's the relationship between the slopes. So again, I'm going to do 3 minus 6 over negative 2 minus 2. So I have negative 3 over negative 4, which is 3/4. That is the slope for AB. Then I'm going to find the slope for CD. So I have 0 minus 3 over negative 1 minus 3, which is negative 3 over negative 4, 3/4. So since they are exactly the same, then I can say that AB is parallel to CD. They're parallel. Or you could just say parallel. So I have to find the slope for both and then compare them. To be parallel, it has to be exactly the same. If one of them is positive 3/4 and one of them is negative 3/4, nope, that's not parallel. It has to be exactly the same. Please keep in mind, if you would have had 6 over 8, that does reduce to be 3/4. So that would still be parallel. To be perpendicular, they have to be opposite signs and flipped over. Not just one of the two things, both. If it was 3/4 and 4/3, but both positive, it would still be neither. To be perpendicular, it has to be flipped over and have different signs. If it's only one of those things, it's just different and they would intersect. Slide down to number 3. So we need to find the slope for both. Lots of finding the slope practice today. So 8 minus 6, negative 1 minus 2. So I have 2 over negative 3. And that was the slope of AB. And then my slope for CD, 2 subtract 3. Always still those y's on top. Negative 1 subtract 3. Having a little deja vu for a second there. So I have negative 1 over negative 4. Now, I could clean that up a bit, but no matter how much I clean that up, they are not the same, right? But they're not different in that special way, so I would just say neither. AB is neither parallel nor perpendicular to CD. Look at number 5. Number 5, I have negative 2 minus 7 over 0 minus 0. Now, I'm just going to let that sit for a second, even though I know it means undefined. I'm just going to let it sit for a second, and I'm going to try the other one. And on the other one, let's see, negative 5, subtract negative 5, and 3, subtract 6. Now, sometimes at first people are like, well, the 3 and the 9 aren't the same. It doesn't matter. Anything with a 0 on top is just 0. And if this one has the 0 on the bottom, it's undefined. So these are perpendicular to each other. One of them is actually a vertical line, and one of them is a horizontal line. Or horizontal line segment, I guess. So they are perpendicular. So if you get one with a 0 on the bottom and the other one has a 0 on the top, that would be perpendicular. If you had two of them with zeros on the top, they would be parallel regardless of if the number on the bottom is the same or not, because 0 divided by anything would just be 0. So we're comparing the slopes. So we could compare the slopes from ordered pairs. Got to do some work there. We could also compare the slopes with equations. And there's a varied amount of work there. So if the equations are in slope-intercept form, then it's pretty easy because I just need to compare the slopes. So in this first one, there's my slope, right? 7. Here's my slope, 7. Are they exactly the same? Yes, so they're parallel. So here's a slope, 4 over 5. Here's a slope, negative 5 over 4. Are they exactly the same? So it's not parallel. Are they opposite and flipped? Yes. So this is perpendicular. They have opposite signs and they're flipped over. So for 11, find the slopes. Are they exactly the same? No. Are they opposite signed and flipped over? No, they're not both. So we cannot say they are perpendicular because they're not flipped. So they are just neither. They're different, but they're not different in the two special ways. If it's not in slope-intercept form, then we need to move it around to get it in slope, to get the y by itself, right? How could I find the slope? Well, if I divide by 3, this one will be, so this 18 divided by 3 is 6. Yes, if I was actually changing the whole equation, I would also do that, but I don't care about that. I care about the 6 because it would be what's in front of the x. Does everybody follow me there? You could do more work, but you don't have to. For the other one, we would move the x to the other side, and then we would divide by 6. So that slope would be negative 1 over 6. So now, one of them has negative 1 over 6, one of them has 6. Are they exactly the same? No, so not parallel. Are they opposite signs and flipped? So perpendicular. By the way, a little Now, it would not help with number 12 because number 12 is not in standard form either. If it is in standard form, where the x and y are on the same side, the slope is always going to be the opposite of the x coordinate divided by the y coordinate. Now, that might, for some of you, that's just one more thing, like I don't want to remember that. You don't have to remember that. But notice what happens. We always move the x over. That's why it's the opposite of the x number. And we always divide it by the y. So sometimes that can make it, if it's in standard form, that can make it quicker. Or if you start to do it to find the slope, just remember, yes, this whole thing is actually y equals negative 1/6 x plus 5. But do I need that 5 for anything in this problem? I do not. So I just didn't do it because I don't need to know that. I am only concerned about the slope. And then you just have a variety of like what they are. 15, when you have 1 and negative 1, that is perpendicular. Because remember, flipping a 1 is still a 1. 16, when you have one that's only a y and one that's only an x, that is also perpendicular. Because one of them is horizontal and one of them is vertical. If they both said x equal a number, they would be parallel. If they both said y equal a number, they would be parallel also. We are not going to do page 57. You can do it if you want, I guess, but I'm not going to ask you for it. It's just more and more practice, okay? It's just more practice. And then I would like you to do evens on page 58. Okay? So 58 is going to be evens. And then I'm going to show you the last thing I'm going to show you today. You're like, oh gosh, please make it the last thing. No. Again, because I know some of you have to leave, I'm just trying to get through all the notes. And then as some of you will work through faster, some of you will need more time, but we've got plenty of time. This is the homework page. Again, evens, I guess, or odds, but I want you to do half of those problems. Number 12 is a pretty easy one, so I might go with evens if I were you, because 12 is a more obvious one than 11. And then this is something new, but it's not really so new. It's really very much what we've already done. So here, you're going to be asked, you're going to be given an equation and a point, and you're going to create another equation that passes through this point, and it's either parallel or perpendicular to the line that you were originally given. So we have to keep in mind what we just learned, that parallel lines have equal slopes or the same slopes, and that perpendicular lines have opposite reciprocals for slopes. So really, it's like the point and slope from yesterday, except I'm going to be a little sly about how I give you the slope. The slope's going to kind of be hidden a little bit. So when it says write the equation of the line that passes through the point, negative 2, 7, and it's parallel to the line y equals negative 4x plus 1, this is just a sly little way to tell you, hey, the slope is negative 4. Because if it's parallel to that line, the slope has to be the same. You have to know that parallel means the slope's the same, and you have to know which of those two numbers is the slope. Which at this point, if you don't, I'm sad. I know you don't want to make me sad. So, negative 4 is our slope, and then now I just do the y equals mx plus b I only have the 1 point. I use that point. 7 is equal to -4 times -2 plus b. So 7 is equal to 8 plus b. Take away 8. I get -1 is b. And then I write the equation. The equation, if it's parallel, should look very much like the original equation. It is completely a coincidence that this is +1 and this one is -1. You will never be using this number at the end. You need to find, your equation is going to have its own b. If it's parallel, it shares the same m. It does not share the same b. So please do not try to work that one into the problem in some way. So the parallel to a line or perpendicular to a line is just another way to tell you the slope. And then you're going to do what you've already done. So while this is new, it's not completely new. It's just another way to use what we've done. Now, if it's in a form like number 2, I got to work a little harder to find the slope. Please do not just say, oh, -3. I see a number. It must be that number. Remember, the slope is when the y is by itself. So the x would have to move over. I'd have to divide by -3. And then that would make my slope +1/3. I don't really care what happens over here. Doesn't matter to me. I only care about the slope. So then I use that slope and the point. So -1 is equal to 1/3 times 3 plus b. -1 is equal to 1 plus b. Take away 1 gives me -2 is b. And then I write my equation. So in that case, we had to do a little more work because we had to find the slope. We cannot just pull the slope off if it's not in slope-intercept form. Could have used that -a/b thing that I told you. If it is perpendicular, do not use the same slope, but you still need to find this slope. So this slope is 2. If that is 2, the perpendicular slope has to be negative, and I have to flip a 2 over. So my new slope is going to be -1/2. And then after you've determined that, you need nothing else from this. Please do not go back there. Now you use that to find your b, and you use it in your final equation. So then I go back to same old, -1/2 times 4 plus b. -2 plus b, add 2, b is 5, write my equation. Putting my m and my b in and using my just x and y. On the assignment on page 61, because I know what you're going to be asked to do on the test, on the assignment on page 61, I want you to do 1, 2, 3, 7, 8, 9. Okay, you're going to do 1, 2, 3, and 7, 8, 9. If you look at them, they are the ones that it's easier to see what the slope is. on page 61. So homework 13, do 1, 2, 3 in the top section, and 7, 8, and 9 in the bottom section. Because when you see this kind of question on the test, that's the way it's going to be. I'm not going to ask you, I'm not going to make you have to find to move the equation around. Okay. Have at it.
1, 2, 3.
1, 2, 3, and 7, 8, 9. So basically the ones where the equations are, yes, because they're already in slope-intercept form. So if it's perpendicular or parallel to a given line, you have to know what the slope of that line is, and then use that slope to find your b. Yes. So the reason this one I made the one like this is because you see these are all already slope intercept form, and I know that that's the way it's going to be on the test. People get a little bogged down with